Okay. Hello. I'm Professor Jong-won Kim at Department of Mechanical Engineering at Seoul National University. Today, this lecture, I will talk about sectional view, right? Okay. So why we have to use sectional view is that since there are many cases that when we try to finish the part drawing, then obviously we have to use many hidden lines. If there are so many features inside the part, then we have to use many hidden lines like this figure. Okay, but actually, I like to ask you to practice from this multi-view drawing. You have to finish the pictorial drawing like this, even if it is made using CAD tools. But what I'm asking you is to finish this pictorial drawing using the hand sketch. Okay. So I like to ask you to practice many times to finish the pictorial drawing from the multi-view drawings. Okay. Anyway, hidden lines make the drawing unreadable. All right. There are so many hidden lines, so it is very unclear to understand what this part is. Of course, if you look very closely at the hidden lines, then you can understand the whole features of the part, but whole shape of the part. But anyway, hidden lines make the drawing unreadable. So sectional view is used to eliminate hidden lines. Like this here. It is a full section. This is a full section. Full section means that cutting lines passes through the whole part here. Okay, so if you have a nice cake, then with a knife you cut it in half. Okay, then you can see the cutting lines. Okay, actually this is a virtual cutting. I don't ask you to really cut the part in two pieces. Virtual cutting. Okay, then. From the then this is the front view. Okay, I remind you that this part is something like ice hockey puck. So very low height, very thin cylinder. So in the case, the front view is selected from the top view, right? So this becomes the front view. Then this is the right side view. Okay. Then the right side the view is made from the projection from the right side with this virtual cutted part. Okay. So then now you can eliminate any hidden lines. So this is a nice full section view, full section, and of course since this is the section view, this pink color means that this is a cutting plane. So the hatching is made to the sectioned area. Okay, this section, the pink area, the hatching. Okay, of course, if you are using CAD tools, then instead of catching, you may apply a little color, not thin color, not a light color into the cutting plane is okay. Okay, instead of hatching line. Anyway. Hatching must be made to the sectioned area to indicate that this is the virtual cutting plane. All right? Okay. Someone would think that since this is the features behind the cutting plane, so you may add that features, this feature here, add this feature using hidden line. Actually, this is a ridiculous way. Why? Why you are using section? Why you are using section? To eliminate hidden line. So, in that sense, why you add the hidden line here? It's meaningless. So, this is quite worse. This is worse. This is ridiculous. So, this is very nice full section view, right? Okay. All right. Now, if when the part is symmetric, absolutely symmetric, then sometimes the cutting plane removes 1/4 of a part, not half, just 1/4 of a part. Then it becomes like this. So the cake, you cut it just 1/4 of a part outside. Then one side of the center line. Now then, if you made a projection view from right side, then the one side of the cutting line shows the sectional view, and the other side the external view. Very nice way. If the part is absolutely symmetric. Okay. All right. So this is a very nice. But since as an external view, since there are so many hidden parts inside, so you may add the hidden line like this to show the hidden features. Then this is also very, very ridiculous drawing. Okay, you may understand why, right? So the reason of using sectional view is to eliminate hidden lines, but you add hidden line here. So this is ridiculous. Okay? All right. All right. Don't worry. Since this is symmetric, so without these hidden lines, you may understand using this multi-view drawing, you may understand what pictorial, what shape this part is. So don't worry. And also there are many techniques for finish the sectional view. So this fixed bracket, cutting plane is not necessarily just one plane. So maybe it has some offset from two planes. This plane and this plane has some offset here. So maybe offset section also very nice way of making the sectional view. So cutting plane is composed of several planes, right? Each of which plane has certain offset distances with each other. So, but in the case, the cutting plane line is drawn by thin single chain line. So thin single chain line, and add a thick full line to both ends and each corner. Okay, this is the Korean standard of showing the cutting plane line. Okay, so AA in direction here, AA. So AA is the A-A symbol is added under the sectional view. So this is a very, very, very nice front view, and this is a top view. And the front view is drawn by using sectional view. And even if the projection is from this, then you may see this line here. So maybe you add the thick line, the external line here. Okay, but this is wrong. Why? This cutting plane is actually virtual, you know. virtual plane. So you don't need to add some thick line here. So okay, just assuming that this plane is moving. This plane is moved parallelly to the same distance with this plane. Assuming that, and then draw the sectional view here. Okay. All right, and add A symbol and the cutting plane line is very important, though. Okay. Add the reference letters and show the view direction. View direction here. View directions. Okay. And this is a typical sectional view examples. So draw the features thin over the cutting plane by visible outline. So which means that this is a cutting plane, AA, cutting planes. So these features are thin over the cutting plane. So that features must be drawn here, by using visible outline. However, do not draw the hidden features by dashed line. Okay, all right. So, all right, okay. The features which are thin over the cutting plane must be drawn on the sectional view here. Okay, all right. So this is the offset cutting plane, and this is a nice examples. Of course, the hidden line, maybe the using of hidden line, there is exceptional cases like C. But before I explain the exceptional cases of using hidden lines, I like to remind you how this sectional view is made. So this sectional view AA, right? AA. And the sectional view BB is from here to this direction. Actually, this is the front view, and this is the right side view, and this is the top view, okay? And AA, how AA is made, AA, then you have to cut the part into half and imagine that the shape after cut in your head, and you have to make the section view in your head, in your brain. Okay. Now I will show you that mechanism using the blackboard. Okay. All right. All right. This is the imaginary the shape after cut. Okay, virtual cut. Then it is cut by half. Okay. Then AA, the front view. AA is made by the projection from this direction. Okay. All right. So that is how the AA is made. CC, you have to imagine the shape after cut like this, okay, and then and the right side view is made from this direction, CC, okay, all right. So that's okay. This is in your head. This is the shape after cut in your brain, and make a projection view from CC and make the sectional view. All right. And now I'm going to explain why the hidden line is added here. Actually, sectional view is used to eliminate hidden lines, but in exceptional case, some hidden line can be added. But this is a very nice technique. So, since as a beginner, it would be a little difficult to understand, but it's like a common sense. So I will explain it using the slide mode. So, okay, now the hidden line here. So hidden line here, right? Hidden line. This hidden line, if without if you're assuming that there is no hidden line here, then you may assuming that this may be extended to the wall over the cylinder, okay? Maybe, or if you're looking at the section, oh, I'm sorry, this is BB, not CC. Oh, sorry. Anyway, if without this hidden line, then you may see just without. Imagine that there were no hidden lines here. Then you just see the rectangular shape over this shape, over this feature, rectangular. Then maybe looking at the feature without these two hidden lines, then you may think that this is just a block, right? Or the cylinder. Maybe you can see. Maybe if you see the center line, then you may see this block is just the cylinder, but it is whole body, not right, whole body. But actually, this shape is the cylinder with the through hole, very large through holes. So if you add these two hidden lines, then you may think that, oh, this is the cylinder with the very large through hole inside. Just from the hidden lines, you may just think that, oh, this is the cylinder with the through hole. So that's why in this case, this is exceptional cases, you add the hidden lines. So anyway, okay. And also this is another technique of aligned section. So cutting plane is virtually aligned in one plane. So which means that this is cutting plane is like this, but actually we're assuming that this section rotating to this axis. This is rotating to the axis. I will show it like this, okay? This axis is rotating in this axis, so this is aligned as a one plane. Then finish the sectional view as a right side view, okay? So without this is not necessary actually. This is not necessary. Just the front view and side view is a multi-view drawing. Then actually this is not perfect based on the projection. Okay, right? Different. The length is different, right? Actually, from the center line to this shape is the real shape of this section. But this technique is the best technique for finishing the part drawing. Okay, so part drawing, if you observe perfect projection, but it does not necessarily becomes the good part drawing. Okay, why? Sometimes observing perfect projection make the drawing unreadable. Okay, so all right. So projected view on the aligned plane shows true length. This is true length from the center line to here. This is true length, right? Okay. So this is another example for showing aligned section. So from A, cutting plane is here. So this part is rotated, aligned, rotated, aligned here, one plane. And this is just moved in parallel here. So this front view shows all true shape, true length and true shape here. Okay, so very nice technique. And maybe this is right side view, but this is just the projection of this area, this surface only. if this part drawing observe a perfect projection, then this part has to be added here. But this is just this area is projected here, so we call it partial projection, which I will explain it next lecture. Okay, so don't worry. Anyway, this is a very nice part drawing. Okay, all right. Okay, this is far from perfect projection. Now you understand me, right? This is nice part drawing. All right. Okay, this is adapter. So this is aligned view. So this section is aligned here as a one plane, and this section is going here. So make a aligned view. So one plane, you make a one plane. That features in virtual one plane is projected here to make a very nice sectional view. So this is the aligned section. All right. Now you may want to know how to draw hatching or section line. Then maybe the hatching lines are drawn by same full line at 45 degrees over 60 degrees to measure visible outlines over center line. So, okay, 45, 45. Or if you are using CAD tools, then you may apply light color in one section, light color. It's okay. But the problem is that if the two parts are combined, then the lines continue in equal space across sectioned areas through, they may be broken by unsectioned areas. So this is a pipe, but one part, so the hatching pattern maintained throughout the one part. Okay, So this is another example of assembly of four parts. Four parts are assembled here. So maybe since you are the beginner, if you see this sectional view, you don't understand what this means. So I will show it using the pictorial drawing using the blackboard. Okay. All right. Now this is the main body. So main body. Okay. That is the and main body, and there's a pipe, and a ring here, and pin here. So four parts are assembled, right? So in the main body, the pipe is inserted, then it becomes like this. So pipe is assembled, then it becomes like this. So pipe is assembled. Pipe is assembled, and you may through hole here. Pipe is assembled into the main body. Then ring is also assembled on the pipe. So if ring is assembled, then it becomes like this. So ring is assembled. Ring is assembled, then it's like this. Then now one piece is the pin. Pin is something like a small metal piece, which looks like a cylinder. Okay, cylinder, small cylinder. Now we call it, this is a pin. We call it, this is a pin. Okay, pin. Okay. Now, what you are going to do with this pin? With just using the hammer, you see the through hole here, small through hole. You may put this pin here, and using the hammer, insert the pin throughout the structure. So if you the pin is inserted, then it looks like this. This is a pin, okay, right? This is pin. This is drawn like using the sectional view in the slide. I will go to the slide. Okay. Now this is a pin. You see? Pin. Now, very important thing is that the pin never hatch. No hatching line it has. No hatching line. Even if it is on the sectional plane, but the pin, you never apply any hatching. Okay? Right? This is very important. If a hatching line is added, then you don't understand what it is. But without hatching line, you can see it. Oh, this is a pin. You know it right away. Especially you transfer, you give it to the technicians in the field, then the technician will understand. If without hatching, then he will understand that, oh, this is a pin. Okay? So never apply hatching line to pin or key. I explained the key element last lecture. Maybe you understand. What was the function of the key? There is a motor shaft, and there was a groove, and pin is inserted. Half of the pin is inserted. The other half of the pin is contacted with the pulley, with the pulley's key home, key groove. Okay? Then what was the function of the key? If motor shaft is spinning, then key is spinning, and key pushes the pulleys inside. So shaft and pulley is spinning as a one body because of the key. That's the function of key. Yeah, the function of a pin is similar, similar. The shaft and ring is combined with the pin, okay? So pipe is spinning, then ring is spinning without any help of friction, okay? Why? Because of pin is connected throughout, okay? That is a very important element. The pin and key are very important. So I wish you to understand the important role of pin here. Pin, okay. Of course, the pin, since the area is very small, the sectional area of pin is very small, so that area, because of that area, the pipe and ring is combined together. So since pin has very small area, so if the external torque is large, then maybe the pin can be break. So key is relatively strong key because the sectional view is large. So if you want the large torque is transferred, then key must be used instead of pin. But pin is when you are dealing with the lower torque, then pin is very nice element of transferring the spinning movement between pipe, motor shaft, and pulley. Okay, pipe and ring, right? Okay, all right. And also there are another technique which we call it broken section. It is used to expose the small portion of the interior of a part by breaking material away virtually, So on irregular boundary is used to show the section. So, okay, small part is broken away, then the small sectional view is made. This is a nice technique, okay? And this is also a nice technique. So key, this is a key. Please remind my explanation on the function of key at last lecture, key. And the shaft, actually shaft and key, no hatching line added. So, but if you try to show how the combination of key and pulley and shaft is made, then you may use a broken section to show, since the shaft is not, hatching line is not added, so just the broken section is used, and the key is shown here, okay? And bolt, also bolt, the hatching line not added, must not be added. So broken section is used to show the status of assembly of the bolt. Okay, so this is a broken way, right? Actually, it is a common sense that if the broken section is made like this, then it makes some confusion. So you may not try it. And also revolved section, it is very nice way. So it is used to show the true shape of the cross section of a part, like the bar, shaft, arm, spoke, or rib of handles or pulleys. So, right? So pass an imaginary cutting plane normal to the axis, then revolve the shape revealed on the cutting plane 90 degrees to the paper plane. So which means that if you just insert the cutting plane and make the true shape on the paper, then rotating it, revolved, 90 degree revolved, and this shows the true shape of the section of this bar. So, and this is added, just added on the drawing of the front view of the bar. This is a 90 degree revolved section, okay? But very nice way of show the real section, real true shape of section on the front view. Nice technique. And this is also revolved section example. So in the front view, cut in some part and revolved section here. And this is nice way, nice way. Sometimes you may using the extension line and add the real shape of the section here. Very nice way. And this is a removed section, very frequently used. And the concept is the same as the revolved section, but it is drawn as separate place. So these are the all removed section. So, but in this case, to identify the matching cutting plane for each section view and its view direction, label them as follows. So this is the front view and top view, and remove the section. AA is here, AA, and direction is here. So since direction is from the right side, AA is made as a right side view. So AA, BB, same. So you see, looking at the removed section, you may see there are so many flow channel crossed inside. Okay, right? BB, AA. And this is a partial view of this area only. Hidden line is added since this is a cut here. So hidden line is here. Then you can make the drawing very readable clearly. So hidden line is added. All right. This is a removed section. So if you see these multi-view drawings, you have to draw the pictorial drawing right away. Right. Okay, this is removed. Removed section many times, frequently used in the field. So this is the real multi-view drawing, part drawing, which I made when I executed the project of developing innovative parallel mechanism machine tool. So this is a top view, front view, and partial view of the left side view. Only this area, only this area is projected here. And section AA, The direction is here. So this is the left side view, all right? Okay. Now, so the homework 9 is that draw a pictorial drawing of the above part. Is the homework 9, all right? Looking at this multi-view drawing, please make a pictorial drawing right away using hand sketch. This is how you read the real partial drawings, part drawing. Looking at the part drawing, in your brain, you have to generate the pictorial drawings of this part. Okay? So the practice is very important. So this is a very serious homework. All right? This is another removed section example. So section AA, and the section view here. So AA is just like a drawing from the bottom side. And this is a shaft, AA, BB, CC, DD, and AA, BB, CC. AA, BB, CC, DD not necessarily drawn in the right side. It can move in parallel to any space in the drawing paper. So AA, BB, CC, DD this is a removed section view. Okay, the direction is very important. So in this example, since direction is the position of a virtual section cutting plane, virtual cutting plane is same, the position is same, but direction is reversed. So AA is as a left side view. So looking at the looking at the AA, the direction is reversed. Understand me? All right? So the direction is very important. Okay, so now, since removed section is very important, so you need the practice. Homework 10, so draw a part drawing of the part as follows by using removed section. Right? Valve A, you can choose a dimension as you wish. Through holes, these through holes, two surface holes, and two face cut is all symmetric. So if the face cut here, then in the symmetric, the face cut is here too. The face cut, and there's another face cut as a symmetric. Okay, so a front view is drawn as a full section. So the front view is from this direction, is a full section. And top view is this direction. From that direction, top view with the hidden line. It's perfect. The top view, the inside features must be made using hidden lines perfectly, completely. And right side view with no hidden line, with several removed sections, and no dimensioning. So it means that right side view with no hidden line, with several removed section is like this here. This here. Right side view, partial view first, and then several removed section. Okay? This is what I like to ask you to practice in homework 10. Okay? Right side view, one partial view, right side view, and with no hidden line, and with several removed sections. All right? Okay. All right? Now, there are many cases that the rip necessary. Rip. Okay? Maybe you can think about some food, rip. Okay? Rip. But anyway, the design of a connector, the why the rips are designed is, the reason is that, for example, on the top surface of the body, you like to fix the pole bar vertically from this plane, vertically, right? There are so many cases that in the street, the power line, the pole or it is assembled vertically to the floor, ground floor, vertical. So many, there are so many combination of the pole vertically stood on the plane. There are so many cases, right? And now, in that case, you need this part, actually. So, firstly, you assemble using bolt, assemble this part on the plane, on the ground, on the floor. Then, if we fix on the using the bolt, then you may try to insert the bar, which you like it installed on vertically on the plane, the bar inside this hole. Then the vertical relationship between floor and bar is made. Now, if you ask that the vertical shape maintained, then what is important? The perfect vertical posture should be made from the plane. Then what is important? You must the assemble scale. Assemble scale should be high. Assemble scale, you see the vertical. So you may adjust. No, the important one is that actually this part, the axis of the cylinder should be perfect with the on the bottom surface of this part. The hole, the machining of this hole should be made very, very precisely. Oh, sorry. Vertical to the bottom surface of actually the accuracy of machining accuracy of this part is very important to maintain the vertical posture of this pole. You understand me? The machining skill is important, not assembly skill. So, and now, assuming that you finish this assembly, then the problem is that if it has the external forces, then maybe this part is very weak for the external forces. So to strengthen the strengthen, then you may apply the rib around it. So between equally spaced hole, you may install the rib, also equal space, right? So actually the rib is very important. Rib is very important. So that means that you are designing this style of part many times. Okay? So now, my question is how you are going to make a part drawing of this part. How? What's the solution? Maybe you can finish like this part drawing like this. Of course, some student may think that since we're assuming that this part is some ice hockey puck, then the front view selected from the top side view. So in the case, then this should be the front view. Then the side view from like this. This drawing has to be here and like this. Okay, the front view and right side view. Maybe that configuration make the drawing horizontally stable. So that would be the right choice. But yeah, this is maybe not better way of selecting the front view. So, but in this drawing, this is the front view and this is the top view. So anyway, please understand me. Anyway, this is a bad front view. Maybe some student may be surprised that why this is a very perfect projection, observe perfect projection, right? And half section view. So this is a section view and this is the external view. Very nice way. But the rib, do not draw rib as sections. It may make you confusion. Okay? If you draw it as a section here, the drawing becomes rather unclear. Okay? So what is the solution? Look at it. Look at it. Compare between this. The rib, do not draw the ribs as a section. Okay? Since it is symmetric, so you don't need to take this, just the symmetric section view, full section view like here. The whole, actually the position of whole is here, so perfect projection, then the center here, but this center, it's like this is revolved. This is revolved here, so whole is here, so then the center is here. Okay? This is a very, very best front view, actually. Best front view. Please remember this. Okay? So, all right? And this is just three ribs, 3 holes. Now, if you observe the projection rule, then maybe this is very nice. This is, you look at it. Wow, this is a very beautiful projection. Wow. Right? Very nice projection. Even if maybe it would be very, very difficult to make it. Anyway, this is the ridiculous front view. The best one is still, this is the best front view. Since this is all symmetric, so, okay, very nicely. Please look at this nice part drawing in your brain, right? Okay, all right. So yes. And parts with arms, lugs, or spoke. Do not draw arms, lugs, and spokes as sections either, as in case of ribs. Okay? So this is spoke. Okay? Sometimes it becomes a complicated and bad drawing, even if you observe the projection principles very strictly. So this is, look at it, right? Just the section view here and symmetry. Okay? And this is a key groove. Key groove is upward, right? Very nice drawing. All right, okay. All right. And maybe this, I will explain it, the assembly drawing. Assembly drawing, if you try to show how the parts are combined, assembled, joined, attached, then the sectional view is frequently used. Show that how the combination inside is made. So you look at it. But fastening elements, parts such as screw, bolt, set screw, nut, washer, key, pin, rivet, and bore and roller of bearings, gear tooth, shaft, etc. These elements parts are not drawn as sections. So see, bolt, ball of a bearing, shaft, pin, bolt, say shaft, right? Gear tooth, these elements are not drawn as sections. Okay, all right. So this is the last homework of this lecture. Draw part drawing for the following part. Bracket A, you can select the dimensions as you wish. All the holes are through, no dimensioning, and draw proper sectional views if necessary. So these are the ribs to support these features above the plane of this body. Okay, so do not draw this as the sections. So maybe you can observe the hint is all here. Hint is all here. Okay, all right. So please make a perfect part drawing of this homework. All right. Okay, this has been the lecture today. Thank you.